It always rain on me. Is it because I lied when I was 17? Why does it all... Oh God, I'm doing a video. Hi there, folks. Yeah, well, bit of a clue as to what you're going to be learning about today from my expertly sung song. I've done it on karaoke a few times. Right, we've studied drought last few lessons. Next is we're going to move on to flooding. So nice and neat and tidy this really, just like with drought. We had physical causes of drought, human causes of drought, and impacts as well. So same really for flooding. So physical causing of flooding, such as storms, depressions, rainfall. Surprise, surprise. Monsoon rains, snowmelt, glacier melt. So all the natural causes. And then similar kind of word that we used when we looked at drought. I mean, you could argue humans don't cause floods. Obviously, if there's no rain, there's never going to be a flood. If there's no snowmelt, there's not going to be a flood. If there's no storm surges, no monsoon rains, no snowmelt, there's not going to be a flood. But what we do, or what people do, through bad planning, people that get paid far too much money to make bad decisions, yeah, and they are the key players what sometimes exacerbate flooding, so they make it worse. All right, and then we're going to have a look at a case study. Sheffield floods 2007. It's right on the doorstep. Right then. Now, as with everything, folks, make notes. Otherwise, it could end in floods of tears. Yeah, if you don't make good notes, sketches, diagrams, write your examples. There's going to be synoptic links galore, so we don't want it to end in tears, do we? All right then. Oh yeah, and if you look in your booklet, page 14, 16 and 17. That's what we're going to cover today. So some of this you need to be making notes on line paper, but it kind of makes sense that, if I'm talking about, let's think, monsoons and snowmelt on page 17, you've actually got a space to write your answer in. So, it's up to you how you do it, but yeah, do it well. All right then, folks. Let's do it. Okie pokey. Right then. First physical cause of floods, and it applies especially to places like the UK, is mid-latitude depressions. Now, we should have kind of learned from looking at El Nino and La Nina, and me banging on about it loads of times, that air pressure is crucial. The air pressure at the surface, at the land surface, is crucial in determining the weather. All right, in particular, whether there's rain or whether it's really dry and settled. So if air's rising, we get low pressure and rain. Now, if that intensifies and it drops even further, then we get what's called a low pressure weather system form. So it's not just simply low pressure; it's actually developed into something more than that. And what can happen after that if it develops even further? It then develops into a Category 1 hurricane, Category 2 hurricane, 3 hurricane, etc. So a hurricane really is super low pressure, all right? A depression is kind of its baby brother or baby sister, yeah? So we do suffer from depressions in the UK. And where do they come from? Well, most of them come from the Atlantic Ocean, all right? If we have a look at this world map, you can see that we've got quite a lot going off. So let's analyse it and break it up. We'll start with, let's have a look. We'll start with the ITCZ. And that stands for the Intertropical Convergence Zone. And what that basically means is it's low pressure. All right, near the equator, but it does move, it does shift northwards and southwards at certain points of the year. All right, but generally speaking, this line near the equator is low pressure. As you move north or south, these two kind of orange zones of latitude, roughly around about 30-35 degrees. We should all know this, it's been drummed into our brains. At those latitudes, then we get high pressure, alright? And we get deserts and a lack of rainfall. So they're the orange bandings on your map. And then it shifts again. As we move towards a higher latitude, we tend to get lower pressure systems near the oceans, generally speaking. So the UK really does suffer from mid-latitude depressions. We're an island nation. We're surrounded by oceans, all right? And depressions bring rain. Simple as that. Yep. Low pressure brings rain. We get a low pressure weather system in the form of a depression. They bring rain. Simple. Okie dokie, folks. Right, well, I think rather than me going into loads... Oh, what's happened here? Going into loads of kind of theory about depressions and warm fronts and cold fronts, I'll do that in lesson, actually, because it is quite tricky. All you've got to remember, keeping it simple, is that low pressure weather systems, which are called depressions, bring rain, right? And there's two different parts that we are concerned with anyway. Two different parts of a depression. We've got the warm front at the front of a depression, which brings drizzle and rain, and then we've got the cold front, which passes over later at the back of a depression, and that brings thunderstorms and heavy rain. All right. Now, depressions rotate in an anti-clockwise direction, so they spin. And if I go back to the last slide, which I'm obviously having great difficulty doing, here we go. Right, if I go back to the last slide, if you've ever seen the weather forecaster, oh dear, right, get rid of that. If you've ever seen a weather forecast on TV, and the girl or lad is, saying, oh yes, well, a belt of high pressure is moving in, or low pressure, we've got a depression moving in. It looks something like this. And L, not surprisingly, is for areas of low pressure, all right? H for areas of high pressure. So in this case, someone that's currently in Spain is going to be receiving dry, settled conditions. Someone that's, heaven forbid, God help them, are living in the Shetland Islands off the northeast coast of Scotland, they're going to be getting a lot of rain. All right. So depressions on a synoptic chart look like tightly packed spirals. All right, and we call these isobars. And you'll see an L, and then it'll really tightly packed in. Yeah. Bit like a mini hurricane. That's sort of what kind of like you visualize a hurricane to look like. That's what it is in effect. It's a mini hurricane, but do not say that in the exam. So these, for the UK, they tend to come from the west over the Atlantic, and they spin and they rotate in an anti-clockwise direction. All right. Right, then we should know quite a bit about depression. So, case study, give it a subheading: Sheffield flash floods 2007. And that word flash kind of insinuates it's quick, sudden, yeah? It's not kind of happened over a long period of time. When it happened, it was sudden. And they can be actually quite dangerous. I think a few people died in the Sheffield floods. Right, here we go. Bullet points then. Let's go. The first one is that there was a series of depression bringing prolonged rainfall. All right. And it had been raining in Sheffield for, well, the UK actually, for around 3 months on and off. And if we have a look at this graph from the BBC News website, it's a bar graph. Oh, let me get rid of all this. Yeah, summer 2007 was the wettest on record, and if we just have a look at this, you've got rainfall levels since 2004, and it's yeah, either side of the mean. So this line here would be the mean or the average, and you can see it's kind of a bit up and down up till then. And then May, June, and July. Yeah, you got three really kind of significant increases. So it had been raining for 3 months. Now that's a prolonged period of time, so prolonged rainfall. And if you kind of combine that with your understanding of drainage basin processes, then you know what's going to happen. Well, the first thing is the soil is going to become saturated. So there's no more room in the soil to store any more rainfall. So it's been raining 3 months, prolonged rainfall, a series of Atlantic depressions has came over the UK one after another, and soil moisture is full to capacity. Right. Next thing, then on the 25th of June, we had intense rainfall. So that's the second cause. Yep. And 1 month's worth of rainfall fell in 2 days. So visualize it, use your imagination. The soil moisture is completely full to capacity. Dams and reservoirs are full. There's no more kind of buffer zone or leeway for those to take any more channel flow. Your rivers are going to be quite full as well. And then on top of that, you get a month's worth of rainfall in 2 days. Yep. Other physical factors that made it even worse was it was a La Nina year, which intensified the low pressure. It didn't help, certainly. And the position of the jet stream was south of the UK. So, next bullet point, La Nina, and the position of the jet stream was south of the UK. Now, in lesson, I'm going to kind of go through how that affected this and made it worse, but just make the bullet point for the time being because it is quite tricky to get your head around. Other physical factors connected to the drainage basin in Sheffield. 5 rivers flow through Sheffield, and there's a lot of what we call confluence points. So where 2 rivers meet, I mean that's not a picture of it, that's just a picture of flooding near the Wash in Rotherham, but where 2 rivers meet, imagine walking through Meadowhall and it's really busy, alright, and 2 kind of aisles either side converge into one. So you've got 2 lots of people walking on 2 separate pathways, then all of a sudden those pathways come together into one. What happens? Everything slows down. You back up, yeah? And that's the same with rivers and their discharge and their channel flow. 2 swollen rivers meet and converge into one channel. It backs up. There's nowhere for the water to go, so it backs up and it overtops its banks. Another kind of thing that helps me visualise this is when it's really busy and it's rush hour. God help us when you lot start driving. Remind me to get my tin hat on. But yeah, stay safe, kids, stay safe. But when you're heading down the motorway slip road and you're trying to merge onto a busy motorway, it's always kind of chock-a-block at the junctions where a motorway and a slip road meet. It will always back up the traffic, and it's similar kind of idea with water in a river channel, really. So here we go then, bit of a recap. Cause of the Sheffield floods: series of depressions, prolonged rainfall for 3 months, intense rainfall with 1 month's worth of rainfall falling in 2 days. 5 rivers flow through Sheffield and meet, and that's called a confluence. Confluence. La Nina and the position of the jet stream was south, but also the kind of relief and the slopes and the valleys in Sheffield. Sheffield sat in kind of a bowl shape and it's surrounded by valleys, and obviously that water in an urbanised catchment will, through the drains and through the tarmac, it will sit on the top. Surface runoff is a lot faster, shorter lag times into the river channel, and it all gets there at once, the river called Cove, and it bursts its banks. Alright? Impacts then. Give it another subheading. Impacts of the Sheffield floods. Do you need to remember all of these? No. I'd say try and remember a good handful. 3 or 4 will do. I mean, it's on the doorstep to you guys, so you should be able to kind of get your head around these quite easy. Meadowhall was flooded and was closed for 3 months. That was quite a positive thing for me because it stopped my girlfriend spending money on my credit card when she went shopping because she didn't have nowhere to go shopping. So that was positive for me, but obviously not positive for the socio-economic losses that businesses and also people that relied on jobs in Meadowhall relied upon. So it was closed for 3 months while they cleared it up. Different reports say different things, but some say 3 people died, some say 5 people died, but yeah, a handful of people died, which is bad in itself. 1,000 evacuated, 1,200 homes flooded. The M1 was closed, which caused chaos. 13,000 were left without power because the electricity substation at Catcliffe at the side of the M1 was flooded. So yeah, mainly socio-economic losses. Right then, lessons learned after these Sheffield floods. If we just think of kind of at different scales, there were lessons learned at a national scale, but also different towns and cities, when they implement those kind of national guidelines, if you like, they do it in their own way through their own councils with the help of national kind of bodies. So this guy here, Mr. Pitt, he was commissioned to carry out a review. Oh God, what's happening here? Yep. And he found a few things out. What Mr. Pitt found was he found that the actual forecasts and weather warnings by the Met Office had been timely and accurate. So you can't blame those people because they did warn people and they knew it was going to happen. But what he recommended was that we needed a kind of joined up approach to flood management. So the Environment Agency, the Met Office needed to work together, created a flood forecasting centre. We need to model floods better so we know which areas are at risk and create flood risk maps. We need to involve the councils, develop probabilistic forecasts and resolution models, also that we can be more resilient to when we get this extreme weather. All right. So he was one key player, Mr. Pitt. We can get rid of him now because he served his purpose. And yep, so there we go. The Met Office did their job, the Environment Agency did their job, and they knew that we were going to get severe floods. As a result of that, what you ended up with was kind of, you're not going to believe it, folks, people valuing maps a lot more than what they did. So, yeah, I mean, this is a flood risk, or the area that was flooded in Rotherham. You can see Catcliffe was hit quite bad, parts of Treeton and the town centre. So, as a result of this, Sheffield created, I'll type it in, called the Strategic Flood Risk Assessment 2008. Alright, so as a result of these national recommendations, Sheffield created its own plan. It's 72 pages long, the document. I've read it all, it's really exciting. Maybe you can go on the council website and have a read. But I've summarised it for you because that's why I'm nice. Basically, you could produce GIS choropleth flood risk maps with low, medium and high risk. Alright, we can use modelling to probability forecast the likelihood of flooding in different places and how severe it's going to be. And the most important thing with that is they can change, the models will adjust and change dependent on, short-term weather patterns or longer-term weather patterns. Yeah, if the climate's changing, these models adjust kind of as we go. Yeah. The assessment and the plan that led after that, the Sheffield flood risk plan, said that communities and businesses would have a say, so it involved local stakeholders. It considered plants and wildlife. It would manage rivers in a positive way that would hopefully reduce flood risk. It would try and keep the valleys open for business, so your Don Valley and your Lower Don Valley, for instance. And it would also consider the downstream impacts of any management, of any river management, and try and ensure that we're not exacerbating flood risk for downstream towns. All right. And that kind of flood plan that the council and the Environment Agency and Met Office kind of work together on to put in place kind of reminds me a little bit of SMPs, shoreline management plans, where stakeholders from local community do get a say, and that doesn't mean to say that they get their own way and every time, but residents, businesses get a say in the plans and the future kind of actions. Yeah. Right then, the next cause of river flooding is monsoon rains. All right, and again on the retail theme, here is my girlfriend's favourite shop when she was about 18, 19. Monsoon. Yep, thought I'd jazz that up a bit. Monsoon rains. Now then, this is interesting. This could take a while. This on page 17. Monsoon rains. Now, what are monsoon rains? Well, they are caused by a seasonal change in the direction of the prevailing winds. All right, so we'll start with basics. Seasonal change in the direction of prevailing winds. And if we look at this map first, no, in fact, yeah, we'll look at this map. Right then. Here we go. So the ITCZ, which we mentioned earlier, equatorial low pressure brings rain. Yep, air's evaporating, rising, cooling and condensing, we get rain. Then we head to around about 30-35 degrees north and south. We get the subtropical high pressure belt, which brings arid conditions and desert. And then we get further north, where roughly the UK is, and we've got the subpolar low. All right, where we get Atlantic depressions and rainfall. So it's kind of the world sort of split up in like a refresher, really, isn't it? Low pressure, high pressure, low pressure, high pressure. Yep. Rain, dry, rain, dry. And while we're on this, at the poles are actually cold deserts, believe it or not. People think of the poles of, receiving lots of rainfall or snowfall, but that's not the case. Cold deserts. Right then, so ITCZ, equatorial low pressure, you're going to need to remember that, because I'll show you this little graphic as well, might help you get your head around it. If this is the equator, then basically we've got warm moist air evaporating, cooling and condensing into clouds, and it rains. Yeah, driven by solar energy. Very first lesson we meet. Solar energy drives the cycle at a global level. But when we've also got winds that converge together, and they pushed sideways as well, all right, or to the west. Now then, if we have a look at this map, we can see how the ITCZ shifts depending on the season. So in July it shifts northward. I've not even used my pen yet, we're 25 minutes in, wow. In July, it shifts north and heads north above India, north of India, and brings with it low pressure and rain. And then in January, it follows this kind of pattern and it shifts south. All right. So yeah, if you want to know what type of monsoon rain or when different locations get different monsoon rains, then it's because of this shifting band of low air pressure. You can refer to it as the ITCZ. I do not need you to spell it in the exam if you don't feel confident. ITCZ will be fine if you just tell the examiner belt of low pressure shifts north. Yeah, and we're going to focus on a case study example of Bangladesh and India. All right. And that, the idea of this ITCZ shifting north and south, depending on the season. So, July it shifts north. Guess which countries receive monsoon rains? Indian subcontinent, Bangladesh. They're the two that we're going to focus on. When it moves south, again, it affects kind of northern Australia, Madagascar, places like that. Yeah, they receive monsoon rains in January, whereas places like Indian subcontinent, Bangladesh, receive monsoon rains from April to September. So, here we are, India, and Bangladesh. Write these case study examples down, very important. Receive lots more rainfall April to September, and it's really heavy rain as well. It's intense. I guess it's prolonged. It's going to be for 3, 4, 5 months of the year. Intense and prolonged monsoon rains. India, Bangladesh, and South Asia. And it shifts north from the equator. It brings warm, moist air from the Indian Ocean, which we can see. Indian Ocean's just here. And that belt shifts northwards and brings with it lots of rainfall to the Indian subcontinent. It drives the low pressure, that's what it is. A couple of facts and figures, write these in the space on page 17. 70% of the average rainfall falls in 100 days. So you get 70% of the average rainfall for the year just in a little over 3 months, in 100 days. And you've also got a map on page 17 of Bangladesh. And another little fact, 80% of Bangladesh, or 80% of the Bangladeshi population is exposed to monsoon rain flood risk. So flooding caused by monsoon rains, if you look at the map, again, if we analyse it and break it up, people that were flooded during the monsoon period, 80% of the country you can see, but Bangladesh, Synoptic link to coast topics. What other risk is there? Well, tidal flooding, which obviously it's in this region called the Sundarbans, where there's a lot of mangrove forests, or there were until people started deforesting it for their own gain, which is again a human exacerbator of flooding, if you want to make a note of that. But storm surges that head up through the Bay of Bengal, head north, cyclones as well, like Cyclone Sidra in 2008, bring storm surges, which is a temporary rise in sea level caused by low pressure, combined with strong winds, very low lying and flat. So that's a second cause for Bangladesh. You've also got the Himalayas to the north, the mountain range just out of map if you like, to the north, and obviously snowmelt, glacier melt in spring and summer feeds loads of rivers, huge rivers like the Ganges, the Brahmaputra, the Hooghly. So Bangladesh is probably one of the most, if not the most flood-prone countries in the world. Monsoon rains, cyclones, storm surges, snowmelt, glacier melt. It is yeah, it is probably the significant factor in Bangladesh that's hindering its development, because it's constantly just responding to one flood, experiencing the socio-economic losses, and then it's cleaned up and it gets flooded again. Yeah, so real nightmare. Right, folks, 30 minutes. These don't normally run much over 30 minutes, so we'll be finished in 2 or 3 minutes, don't worry. Yeah, next physical cause of flood. Give it a subheading: snowmelt, glacier melt, jokulhaups. Again, synoptic link central with jokulhaups to tectonics topic. So, snowmelt, glacier melt, just make notes on this. Mountainous regions such as the Andes and the Himalayas, obviously lots of snowpack, lots of glaciers. They can melt suddenly or thaw suddenly in spring and summer. Alright? And yeah, also, so that's kind of like your mountainous regions, which is altitude. So glaciers at higher altitudes melt. But also glaciers and ice caps and ice sheets at high latitude melt. So if we think of countries like Alaska, Siberia, Russia, head north, 70, 80 degrees north at equator, very cold, but they can actually warm up as well in spring and summer, and that can cause rivers regimes to swell. Yeah, so link it back to river regimes. It increases river discharge, and so river regimes are affected. What is particularly a factor as well, and this might take a little bit of getting your head around, but you imagine if you get rapid melting of glaciers and snowpack at higher altitude, so further up the mountain, yeah, but it doesn't melt as fast, so it doesn't melt at lower altitudes, then just visualize that. What will happen is the glaciers will melt up on the mountain tops. That water flows into river channels and through the catchment, but it can't infiltrate because the ground's frozen. Yeah, so that can obviously less infiltration, more surface runoff. The synoptic link is to jokulhaups, where the heat from volcanoes can melt an ice dam, which causes flash floods. We've got a few pictures. I think this is Canada, this one, where we've had snow melt. This one's glacier melt, and these two are a result of jokulhaups causing sudden flash floods. Yep. Right, folks. Synoptic links galore with this. Let me just recap. We have got depressions and storm surges affecting the UK coastlines, which you can link to coast topic with storm surges increasing rates of erosion. What else we got? We have got key players and stakeholders and their role, such as the Environment Agency, Mr. Pitt, the Met Office, yeah, for the Sheffield floods. We've got synoptic links for Bangladesh as a case study example, at risk from storm surges, from cyclones, coastal flooding. You could even link Bangladesh to globalization a little bit, I guess. Fact that it's probably switched off from globalization to a large extent because it's kind of physical factors such as being at risk of flooding. And then you've got a link with jokulhaups to tectonics topic. All right. Like I said, make good notes. We don't want it to end in tears and in floods of tears. So I need to get better jokes, don't I? I can only think of one. Let me pause it and think for another 1 minute. No, my mind's gone blank, so that's it. So yeah, if you need to watch bits of this back, I know it's kind of 35 minutes long, but yeah, don't just skip through it quickly. Make detailed notes. If you have to watch it again, Let's do it right. All right. Bring your notes to lesson, whether it's online or whether you've been on line paper and you should have filled in bit of 14 maybe, had a read of 16, and then page 17. Right, adios.